Welcome to this new lecture on differential equation. In this lecture, we will try to find the general solution of the given equations, given differential equations. It is Anjan Kumar Thakur for my Saptrisi Mind Your Edutech. I welcome you all. So let us have the questions and solutions. So it is the first six video on this topic. And it contains the solution of exercise 9.4 of the NCERT book. Friends, it will this video will show you the exercises of general solution of the given differential equations. Why general? Because it will contain some arbitrary constants like C, A, B, whatever, right? Other than the variables. So now let us come for the solutions. In this collection, we will try to find the general solution of the given equation, and then here it goes. Now we have the first question of the exercise, and the question is that dy by dx is equal to 1 minus cos x upon 1 plus cos x. As our first rule, we know that we will change the 1 minus cos x and 1 plus cos x into sin x and cos x per our trigonometrical formula. So what we do, the given equation is this, and then we change 1 minus cos x into 2 sin square upon x upon 2, and 1 plus cos x as 2 cos square x upon 2. Now 2 will be cancelled and will change into 10 square x upon 2. Now 10 square x upon 2 will change into sec square x upon 2 minus 1. Now separating the variables, what will come? Dy will come this side, and dx will come this side, and dy will remain as it is. So now it becomes dy equal to sec square x upon 2 minus 1 whole dx. Now integrating both the sides, what we get? Integration dy, this is the term. Now separate it. So integration sec square x upon 2 dx minus dx, integration dx. So what we get the value? So it is y equal to 2 tan x upon 2 minus x plus c. Why 2? So sec square x upon 2 will have an integration as tan x upon 2, but this x upon 2 has the integration as 2, not only 1, it is 2. So the general solution of this equation will be y equal to 2 tan x upon 2 minus x plus c. This c is very important. If we will change this c, we will get the particular solutions. So this is a general solution. Now let us come for the next question, and next question is dy upon dx is equal to square root 4 minus y square. Here y is limited to, will not be usually greater than 2, and then 2 minus 2 and 2 will not be included in this list, right? This is a condition, but we have not to consider about that because we are getting only general solution. So what we do? Equation is this one. So separating the variable, so which becomes dy upon square root y 4 minus y square is equal to dx. If you know a square minus the square root of a square minus x square integration, then we can find it. And integrating both the sides, we'll get that dy upon square root of 4 minus y square is equal to integration dx. So how it works? Sine inverse y upon 2. It is differentiation of means dx upon square root of a square minus x square is equal to sine inverse x upon 2. It is a formula, you must learn it, or we can derive it also, but we will do it in the chapter of integral calculation. Right now it is to be remembered that integration dy upon 4 minus y square will have the integral as sine inverse y upon 2, and dx has integral as x plus c, and this is the, and now we can solve it. So this part is also the solution, and that part is also the solution. So y upon 2 is equal to sine x plus c, or we can write y equal to 2 sine x plus c in bracket. This is the general solution of this equation. So we are getting this one. Now in the third question, what we get? just see. In third question, dy upon dx plus y is equal to 1. Again, we will separate the variable. So how will you do it? This dy plus y dx is equal to dx. It is by taking LCM and adding it and taking the dx on that side. Or if you multiply both sides by dx, we will get the dy plus y dx is equal to dx. Now, what happens? We will dy is equal to 1 minus y dx, because y dx will go on the right hand side, and after taking common, we'll get this one. So by separating it, what we get? We get that dy upon 1 minus y is equal to dx. Now integrating both the sides, we will get dy upon 1 minus y integration is equal to integration dx. Now in the next slide, so just start in the next slide. So in this next slide, we'll find that this is our equation. Integration dy 1 minus y is equal to dx. We know that 1 upon x dy, its integration is 1 upon x dx. Its integration is equal to log x. But here 1 minus y, so it will become minus, integration will be minus log 1 minus y is equal to x plus log c. We have taken log c as a constant. C is constant, so its log will also be constant, because it will give our solution a very beautiful look. First, let's see it. So minus log c minus log 1 minus y is equal to x. Now minus log c into 1 minus y is equal to x. So again, c 1 minus y is equal to e raised to power minus x. You know it. If you know the logarithm, then you know this method also, this thing also, that if log goes this side, then it becomes e raised to power the variable. Right now, what happens? So 1 minus y is equal to 1 upon c, e raised to power minus x. And if we put, then we can write also that y equal to 1 minus 1 upon c in bracket e raised to power minus x. Now, if we put minus 1 upon c equal to a, then what we get? Y is equal to 1 plus a e raised to power minus x. And it is the general solution of this given equation. So this way we are reaching at the end of this lecture. So this is, thank you for watching this, and wait for the next part. So thank you very much for watching, and I, Anjan Kumar Thakur, sign off. If you find our effort commendable, please do share, like, and subscribe this channel, Saptasi Mind Where You Take. So thank you very much, and thank you.